AI and machine learning are built on data, big data, lots of it. So much that to make sense of it, we have to have it in a visual format, and we also have to have access to data in order to analyze it. So, in fact, AI and machine learning have transformed what we mean about data. For example, if you think of data, you may think of, gee, as a teacher, I assign kids to do a survey. They record their results on tablet paper and compile them, or maybe in a spreadsheet. That's fine. But the data from sensors in like a modern self-driving car can produce up to 25 gigabytes of data every hour. That's more than will fit on any spreadsheet. We need programs, we need systems to analyze this. And when you learned variables, you learned to graph an x and a y variable. And in statistics, you learned the dependent and independent variable. You're graphing two things. But in the real world, there are more variables than that. Graphing two variables is like a toy project. Machine learning can manipulate over 1 million variables simultaneously from multiple data sets. And once again, like Scratch, we're going to use a tool that is fourth grade accessible, but in this case, older kids can dive much more deeply into the data, analyze data of their own, and really, really learn. So let's look at this tool. This is a tool from Gapminder called the Bubble Graph. And we're looking at life expectancy versus income. So those are our two main variables. Each bubble is a country. The size of the bubble is the population. The color of the bubble is the continent. So the big red bubbles, for example, are China and India. The big green bubble here is the US. Blue bubbles are Africa. But this is not a static graph because there is a timeline on the bottom. And if you click this white triangle, the world will progress. You can see 200 countries changing their life expectancy and income over 200 years, from 1800 to 2018. While you watch, in less than 2 minutes, you'll be seeing a graph that is live generated by 125,000 data points. Imagine compiling that many survey results. Well, this is great if you look at all the countries, but let's imagine we wanted to compare two countries, the growth of the U.S. and China. So here's China in 1800, the U.S. in 1800, and actually this is the U.S. in 1800. And you can see how over the past 200 years we've grown. We've grown in size. You might think we're graphing just life expectancy and income, but we're also graphing countries. That's 3 variables. On continents, that's 4 variables. The population is shown, 5 variables. And we can stop and look at any year. That's 6 variables, all in the easy to understand systems. Well, this is great if all you want to graph is life expectancy versus income, but how about if we wanted to learn about, what part of the world is ready for AI and machine learning? Well, maybe we could graph cell phone ownership if we can find that. Well, it turns out that the buttons for life expectancy and income are not just labels, those are buttons. If we click on the life expectancy button, we get this list of categories. So we can find data sets from economics, education, and so on. And phones would be under infrastructure. If we click on infrastructure, then we can see, here's communication as one kind of infrastructure. If we click on that, we can see, there's personal computer, internet, cell phones. Okay, how about cell phones per 100 people? If we click on that, we get a different graph. I've added some things. So this big red line is at the 100 cell phone per 100 people mark. In other words, all the countries on that line have, on an average, one cell phone per person, meaning they are ready for AI and machine learning. Well, here's the US. That's above the line. We have an average of more than one per person. But on the line, countries from like rich countries, Ireland, China, Iran, Egypt, all the way down to poorer countries like Senegal in Africa. Half of the world or more is ready for AI and machine learning now through the phones in their pockets. If we were to animate this and show it to present to a group, it might be a little too fast for them to follow. So there's a little control down here, right here, that lets you control the animation speed, which is a really cool thing. So how about if you wanted to get this data yourself to run through a machine learning project or graph in some way of your own? Well, on the Gapminder home page, Gapminder is the source of the bubble charts. The bubble charts come under Tools, but there's a data button, and the data button gives you access to over 100 data sets from respected outfits like United Nations, International Labor Organizations, World Health Organization, World Bank, and lots more. Just to recap, for AI, because of sensors, partly, we have massive amounts of data that take an automated system to analyze. We can work with many more variables than the X and Y axis that you've learned. From multiple data sets, we have over 100 accessible in Gapminder, which is, again, fourth grade accessible, free and web-based, runs on any system. And in this case, older kids can really dive into it more deeply. How about this image of the universe? Where does that come from? Well, maybe each one of these rectangles is a camera image taken through a telescope. Visually, we can make sense of it. We can interpret it, even though that image contains over 1 billion data points. Wow. So as you finish these activities, reflect on the role of data. How can you find data? What's producing it? What can be analyzed? And you have another practical hands-on tool with Gapminder's bubble graphs that can be used easily from 4th grade to 12th grade. And this fits into curricula, for example, social studies, science, math, obviously, computer science and technology. But you can graph literacy levels for things like reading. So I hope you'll enjoy these activities.